This is the video for accelerated geometry on section 7-3 on compound events. This first video on compound events, we will focus on how to create Venn diagrams to help us find the probability of the event. So key vocabulary that we're going to see is simple event, compound event, mutually exclusive events, and inclusive events. The essential question is, how do you find the probability of mutually exclusive event and an inclusive event? A simple event is an event that describes a single outcome. A compound event is an event that is made up of two or more simple events. Mutually exclusive events are events that cannot occur at the same time. So for example, rolling a 1 and rolling a 2 on the same roll for a number cube cannot happen. Therefore, they are considered mutually exclusive events. Venn diagrams for mutually exclusive events do not touch. So event A does not touch event B. Example 1 says a group of students is donating blood during a blood drive. A student has a 9 out of 20 probability of having type O blood and a 2 out of 5 probability of having type A blood. Explain why the events type O and type A are mutually exclusive. This is because a person cannot have more than one type of blood. When we create the Venn diagram for this, we're going to start off by drawing a circle and labeling it type O. The probability for type O was 9 out of 20. And then we have type A with a probability of 2 out of 5. And then we can put a box around it. And this box is just showing that these are representing the blood types. So I want you to try the next one. It says each student cast one vote for senior class president. Of the students, 25% voted for Hunt, 20% voted for Klein, and 55% voted for Villa. A student from a senior class is selected at random. Explain why each of the events voted for Hunt, voted for Klein, and voted for Villa are mutually exclusive, and draw a Venn diagram to represent this situation. So the reason why that these are mutually exclusive is because a student can cast only one vote, so they can't vote for more than one person. And then your Venn diagram, you have the three people in separate circles that do not touch and their respective probabilities or their percentage of votes that they received. Next, we have the concept of inclusive events, which are events that have one or more outcome in common. When you roll a number cube, the outcomes of rolling an even number and rolling a prime number are not mutually exclusive. They're what we call inclusive because the number 2 is both a prime number and it's even. And when you draw those circles out, because the even numbers are 2, 4, and 6, the prime numbers are 2, 3, and 5, and you can see that both circles share the number 2 because 2 is both even and prime. I also want to make note here that inclusive events are also known as overlapping events. And one of the reasons for this is if you look at the Venn diagram, you can see that the red circle and the blue circle do actually overlap. Some examples. We're rolling a number cube. We want to draw the Venn diagram for rolling a 4 or an even number. Is it mutually exclusive or inclusive? Well, because 4 is also an even number, it is inclusive. So we have one circle where we're going to put all of our evens, which are 2, 4 is going to be in the middle, and 6, and then the number 4. So the only number 4 is the 4 where it overlaps. And if you want to put the box, you can here, and it would be labeled rolling a number cube. What about drawing a card from a standard deck of 52 cards? Draw the Venn diagram for picking a red or a face card. Is it mutually exclusive or inclusive? And again, this is going to be inclusive because there are red face cards. So I'm going to start off with my circle, and it's going to be red. And then I have another circle with my face cards. Now, before I actually put my numbers in this, I'm going to think to myself, I know that a standard deck of cards is only 2 colors, red and black. So half the card is red, or half the stack is red and half the stack is black. So 52 divided by 2 is 26. So there are 26 red cards. Face cards, there's 3 face per suit, but 4 suits. So 3 times 4 is 12. So there are 12 face cards. However, there's 2 suits that are red. So if each suit has 3 face cards, that means that there are 6 cards that are red and a face card. So that 6 has to go where they overlap. Then the important thing is to remember that this whole circle has to add up to be how many face cards there are. So if there's a total of 12, but we've already accounted for 6 of them, 12 minus 6 leaves you with 6. Again, the red cards have to add to be 26, but we've already accounted for 6 of them, so then this out here is 20. Let's try some word problems. Okay, so example 5 says of 1,560 students surveyed, 840 were seniors and 630 read a daily paper. The rest of the students were juniors. Only 215 of the paper readers were juniors. Draw the Venn diagram for the situation. So first thing I'm going to do is draw out my 2 circles. And we're talking about seniors. And we're talking about, oops, let me redo that. And we're talking about reading the paper. So off to the side, I'm going to do some mental math here. So I know that there's a total of 840 seniors, and there's 630 people who read daily. There's only 215 were juniors. So that means of the 630 readers, there were 215 of them that were not seniors, because it tells you in the problem that they're either a senior or they're a junior. So of the 630, if I know that 215 were juniors, so if I subtract the 215, that leaves me with 415. So that tells you how many were both a senior and reads on a daily basis. Then for my seniors, this whole circle has to add up to be 100 or be 840, but we've already accounted for 415. So we're going to subtract the 415 out, and we are left with 425. and these were students surveyed. Okay, I want you to try this last one for yourself, so I'm going to pause the video, and then when it comes, I would pause it myself on your end so that when you hit play again, you have the answer to see whether or not you did it correctly. Okay, so your Venn diagram should look like this. You should have that 63 of the 96 that got their hair styled did not have a manicure, so they just got their hair styled. That 33 got their hair styled and got a manicure, and that 28 only had the manicure. Now, explaining what I did tells you right here in the problem that only 28 had, or that 28 only had a manicure, so that automatically tells you this number. But then I know that 61 people had the manicure, so when I subtracted the 28, that gave me the 33. But then I knew that this whole circle had to add up to be 96, so 96 minus 33 left me with the 63.